Okay, so today the last topic that we need to add in terms of operations with polynomials is dividing polynomials. Now, when we went through multiplying, we talked about all the different options so that we could figure out and understand how to multiply no matter what we were given. We're not going to do that with dividing. Dividing polynomials gets its whole entire own unit in second year algebra. Okay, dividing polynomials opens a whole other door to a lot of things. So we're only going to be looking at dividing in one specific way. And we're going to be looking at dividing a polynomial by a monomial. And I would say that the most challenging part of this unit is that there are different division signs, and some of them we haven't seen for a while. Otherwise, there is nothing tricky about this. Okay, if I were just standing up here teaching division, we are now in algebra. What type of division sign do we use at this level?
A
fraction bar.
The dot is multiplication.
Okay, so if I have 12x to the third plus 24x squared minus 30x, and I want to divide this by 6x. And then we are just going to treat these as individual pieces. Okay, so all we're going to do is we're going to take this denominator, okay, and divide each individual piece. So let me give you a reminder here about adding and subtracting with fractions, because I think some of us might forget. So we have 4/3 plus 2/3 plus 8/3. What would we do to add these?
Straight across.
We would just add all this top stuff and then keep the denominator the same. Right? So what's really happening here is this is just 3 fractions with the same denominator. So this is really 12x to the third over 6x. 24x squared over 6x. And negative 30x over 6x. And then we will just look at them as individual pieces and divide by the rules that we already know. So 12 divided by 6 is 2. And when we divide, what do we do with exponents?
Subtract.
Subtract. So 3 minus 1 is 2. Okay, positive 24 divided by 6 is 4. 2 minus 1 is 1. And then we'll do the last piece. Negative 30 divided by 6 is negative 5. 1 minus 1 is 0, so it goes away.
That's the answer.
And that's our answer.
Oh my gosh.
Okay, so really as long as you know your rules of division, you're fine here. The thing is that division can be written in different formats, which means we also might see something like
Yes.
I hate that kind of.
right? This is division as well. And so while this division sign is different, the actual problem or way that we do the problem is exactly the same. Okay, just because we use a different sign doesn't mean we multiply a different way, right? So just because we use a different division sign doesn't mean we divide a different way. So we'll divide each of these by 5x to the 5th. So what is 20 divided by 5?
4x to the third.
X to the
It's
2 squared, x squared. Right? Negative 45 divided by 5 is negative 9. And then the x goes away.
There's your answer.
And there's our answer. Okay, so we're going to look at one more here.
I cannot
Okay,
fit
buddy.
this on a piece of
Okay.
paper.
Okay.
I was writing the first two numbers and then I was like, whoa.
So we have learned this consistently throughout this unit. When I put a problem up here and we go, oh, I can't do that. Has it really ever turned into a problem that we can't do?
No.
No, right? It's taken us longer to complete it. It takes more time. It does not require us to know any more information. Okay, it is the one fantastic thing about polynomials. Okay, our exponent rules just stay the same. So this is still division, which means what should we be doing with that 2x squared y? Colin?
Dividing them, not together, but.
Right, so each individually
Yeah.
is getting a division. So I'm dividing each piece separately. So what do you say, Izzy?
It's Lizzie.
Oh, Lizzie, sorry, I don't know why I didn't put that in there. What did I say?
You
Hey,
said
shorter.
Oh, I just missed the L, I don't know.
8x third y to the second.
Okay, so where did you get that 8x third y to the second?
16 divided by 2.
16 divided by 2 is 8. Lord, I'm ready for Friday, apparently.
5 minus 2 is 3.
5 minus 2 is 3, right? Because when there's multiple variables, we subtract in the ones that have the same base.
And then 3 minus 1 is 2.
When we don't see an exponent, it's really a 1, so 3 minus 1 is 2.
Yeah.
And we'll just continue that process across. 22 divided by 2 is 11.
X, Y.
1.
3 minus 2 is 1. 2 minus 1 is 1.
Minus 1.
2 divided by 2 is
Negative 1.
2 minus 2 is
Zero.
gone.